Hello friends, in this session we will learn about the sets, types of sets, representation of sets with some examples. So first look on the definition. A set is a well defined collection of objects. Here well defined means easily we can decide whether one object in that collection or not. Like if we are taking the collection of odd numbers, then 1, 3, 5, 7, these all are in the collection. 2 will not be in the collection. So this is well defined. Collection of all natural numbers. Here also we can say 0 is not in the collection. But if we are thinking for some good children from your class, from your neighborhood, from somewhere, then we don't have the criteria for good, for bad, for some talent. Like in your class, if you are going to select the brilliant student based on some examination, then we can decide. But without rank, without the position, we cannot decide who will be most intelligent. Means on fixing the criteria only, that collection will be well defined, and then that collection is known as set. And sets are usually denoted by capital letters of English alphabet, A, B, C, D up to X, Y, Z, all this. Here we have some more examples. Set A, the set of all natural numbers. So clearly 1, 2, 3, 4, 5, all this up to infinity. The solution of the equation x square minus 5x plus 6 equal to 0. So this equation we can solve by any method, and result will be 2 and 3. So here 2 and 3 are in the set B. In set C, the vowels in English alphabet. So clearly we have A, E, I, O, U. So in this also we can say B, C, these are not in the set C. D also not, because well defined. This is the criteria. The collection of books in our library, this is also well defined. If you are thinking for top batsman, top cricketer, then directly we don't have the criteria. Based on some ranking, like ICC ranking in 2020, we can say this is a top batsman. But directly top batsman who will be? We don't have criteria. Then that collection will not be the set. The collection or sets are represented as capital letters of English alphabet, while the elements or objects or members of the sets are represented by small letters, small ABC. Now every sets can be represented in two different ways. First one is roster form and second is set builder form. In first roster form, all the elements are listed. Here all the elements will be listed in the set. This form is also known as tabular form. For example, if we are writing A equals to the set A equals to A, E, I, O, U, as these are the vowels in English alphabet. But here all the elements are listed: A, E, I, O, U, all are here. Another example we can write as 1, 3, 5, 7, 9. Here also all the elements are listed. Even if we are not able to write up to the infinity, but 1, 3, 5, what are the elements? Easily we can see. So this is roster form. We are tabulating the elements. Now in second, set builder form. In this, we have to write all the elements based on their properties, not in listing. All the elements of a set possess a single common property and which is not possessed by any other elements, like here. The same set can be written as in set builder form, but here what are this? The collection of vowels in English alphabet in a statement form. Or the same thing we can write x such that x, where x is a variable. X, A is the collection of x, where x is a vowel of English alphabet. So this is set builder form. Similarly, for same group B, we can write x such that x is an odd number. So we can have the same 1, 3, 5, 7, 9, 11. Here in this example, x such that x is a vowel of English alphabet have common property. This is the common property possessed by only A, E, I, O, U. So in set builder form, all the elements have that common property, single common property, which is not possessed by any other elements. So by looking this, we can decide which alphabets are in this group A, set A. Now, here this small a is the member of set A. One member. Second member is E. So this member element are represented with a symbol, and that symbol is belongs to. This is the symbol for belongs to. Small a belongs to set A. Small e is an element of set A. Small I is a member of set A. Element, belongs to, or member. All things are same. So let's we'll discuss with some more example. In this example, we have two sets. In set A, elements are 1, 2, 5, 7, 9. This is in roster form because elements are directly listed. And set B is in set builder form. X such that x is a natural number less than equal to 5. So here the same thing we can write in roster form also. So in roster form, B equals to, just look on the common property, natural number less than equal to 5. So this is 1, 2, 3, 4 equal to 5 also. 5. So here 1 is an element of set A. So this we can write belongs to set A. 2 is also belongs to set A. 3 not belongs to, does not belongs to set A. So this should be cancelled. 3 is not there. What about 10? 10 belongs to or not? Yeah, it is not there, so not belongs to. So by looking in roster form, we can decide whether the elements belongs to the set or not. Here 1, 2, 3, 4, 5 belongs to set B, but 6 not belongs to B. So in this condition, 2 belongs to set B. 4 also belongs to set B, 1 belongs to set B, 2 belongs to, 6 not belongs to set B, 10 also not, 9 not belongs to set B. So this is the belongs to or not belongs to based on if it is an element or member in the collection or not. Now based on the elements, we will have some types of sets and we will discuss on that. The first one is empty set. Empty sets having 0 elements. A set which does not contain any element. Then why it is called a set? Because from the definition of set, a well defined collection, that should be collection. But in this collection we don't have any element. Like that collection is emptied. If it is empty, then considered as empty set. While you are in class and strength is 40 and all are attending the class, then that collection number is 40. And after the class, if you are going home, that classroom will be empty. In that condition, it will be considered as empty set. And this empty set is denoted by two types. Here no element in the bracket, so empty set, or phi. Phi stands for empty. Sometimes this empty set is also known as null set, no elements, or void set. If the number of elements in any set is 0, then that set is known as empty set. Number of elements in set A equal to 0. So this set is empty set. Next, finite set. If a set having fixed number of elements, finite number of elements, like the vowels in English alphabet, here number of elements will be 5 fixed. But if we are thinking the collection of natural numbers, it is not fixed. We cannot say only 100, we cannot say only 10. So in finite set, the number of elements will be fixed, definite. The number of elements in the set will be fixed or definite. So any example we can use, like if 1, 2, there are 2 elements only. 1, 3, 5, 7, 9, these are all numbers, but if till 11, then it is finite. Next is infinite. Now easily you can decide which set will be infinite if number of element is not fixed. Infinite number of element, the set of all natural numbers, the set of all odd numbers, the set of rational numbers, the set of all the points on a line segment. In line segment, the set of all the points. So how many points? 1, 2, 3, 4, many possibilities, infinite. So this kind of sets are known as infinite sets, where the number of element is infinite. Here the number of elements will be finite. In this condition, number of element will be infinite. Now next type is equal sets. Here we have to compare two different sets. In two sets, if the elements are same, all the elements are same, then the sets are known as equal sets. Means every element of first set is also in second, and every element of second set is also in first. You just think for any two example. Just here I am writing set A. Just you think for two different words having same letters. Words will be different, but letters will be same. Have you any? Letters of simply dog. So here what are the letters? D, comma O, comma G. And now letters of God having same. Here also D comma O comma G. These are in set builder form. While we are writing in roster form, then A equals to, it is D G O as per the order of English alphabet, and B here again D G O. So these are equal sets. Now we will discuss on subset for any set, and this we will discuss in our next session. And in the same session we will again review the definition of sets, examples, type of sets, elements, belongs to, member, and what will be the well defined collection. Thank you.